Okay, so let's go over this homework right here. So first of all, if we start at home plate here, right, our distance is 0 and displacement is 0. Duh, right? If we go to first base, this whole length here is 90 feet. So that our distance from that we've traveled is 90 feet, and our displacement is 90 feet. If we go to second base, we have traveled another 90 feet in distance. So now we're at 180 feet. Okay, but we need to find out what is our displacement. Our displacement is the distance from our start to our end point. So this would be our displacement here. So I gave it to you. I said it was 127. Okay, 127. If you really think about it, we could figure it out, but I gave it to you. Made it really simple on you. Okay. Yeah. Next, if we go to third base, so we're traveling another 90 feet. So we travel 90, 90, 90, that's 270 feet total distance. But our displacement is actually only 90 feet because we're only 90 feet from where we started. Okay, now when we get back home, we're traveling another 90 feet, so we're adding another 90 feet here. So 360 feet. It's 360 feet traveled. But our displacement is going to be 0 again. Okay, so no real calculations there, just kind of a thought experiment there. And that's why I gave you 127. I didn't want you to do any actual calculations. Okay. Next, a runner at a track meet completes exactly one lap around a 400-meter track. So if you go one lap around, that means they traveled 400 meters. The distance, that's the distance. The displacement is 0. We didn't move anywhere. We're wound up at the same spot. Now, if we do 2 laps around, that means we move 800 meters, but our displacement is 0. Doesn't matter what the units are because 0 is 0. Okay, for any object in motion, distance is always greater than or equal to. It's either going to be greater than or equal to the displacement. Next, a swimmer swims a half lap, meaning they move from the left end of the pool to the right end of the pool. They start here, end here. That means they traveled a distance of 50 meters, and their displacement is 50 meters. So same. Now a swimmer swims an entire lap. So it goes from one side to the other and then back again. So the distance traveled is 100 meters. Displacement is 0. Easy peasy, lemon squeezy. Now let's talk about vectors. Okay, so this is very similar to what we did in the lecture. Sorry, I gotta drink some water there. So I went for a walk the other day. I went 4 avenues east, 24 streets south, 1 avenue west, and 8 streets north. Okay, all those distances are given to you there. So what distance did I travel? I just add them all up. So 0.8 plus 1.2 plus 0.2 plus 0.4. And we get 2.6. 2.6. 2.6. 2.6. 2.6. 2.6. 2.6. 2.6. 2.6. 2.6. 2.6. 2.6. 2.6. 2.6. 2.6. 2.6. 2.6. 2.6. 2.6. 2.6. 2.6. 2.6. 2.6. 2.6. 2.6. 2.6. 2.6. 2.6. 2.6. 2.6. 2.6. 2.6. 2.6. 2.6. 2.6. 2.6. 2.6. 2.6. 2.6. 2.6. 2.6. 2.6. 2.6. 2.6. 2.6. 2.6. 2.6. 2.6. 2.6. 2.6. 2.6. 2.6. 2.6. 2.6. 2.6. 2.6. 2.6. 2.6. 2.6. 2.6. 2.6. 2.6. 2.6. 2.6. 2.6. 2.6. 2.6. 2.6. 2.6. 2.6. 2.6. 2.6. 2.6. 2.6. 2.6. 2.6. 2.6. Okay, what's my resultant displacement? Okay, so this involves a little bit more difficult calculations because we have to use the Pythagorean theorem. So first, we look at the ones that are parallel to one another, so east and west. So we travel 0.8 east and 0.2 west. So we add those together, or really subtract 0.8 minus 0.2, and we get 0.6 east. So we're going to go 0.6 miles east, and then we look south then north. So south minus north, 1.2 minus 0.4, and we get 0.8 miles south. So that means we move 0.6 east, 0.8 south, and our resultant vector will be this one. So we use the Pythagorean theorem, 0.6 squared plus 0.8 squared, take the square root of it, and we get just so happens to be 1. And the direction would be southeast. Next one, an ambitious hiker walks 25 kilometers west and 35 kilometers south. Find the magnitude of her resultant displacement. Okay, so we have 25 kilometers west, so 25, and 35 south. We want to find the resultant displacement. So we know it's going to be southwest is the direction. And then it's 25 squared plus 35 squared, the square root of that. And we get 43. So we wind up 43 kilometers southwest of where we originally started. Okay, so this one says draw the following on the graph. Start the bottom left corner and circle the endpoint at the end. So we're starting at the bottom left-hand corner here. We're going to go 10 blocks east. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We're going to go 20 blocks north. So 1, 2, 3, 4, 5, 6, 7, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Ooh, that's a lot. 10 more east. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 blocks south. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 5 blocks west. 1, 2, 3, 4, 5. 5 blocks north. 1, 2, 3, 4, 5. And then that's the end. So that's the end point right there. Okay, we want to know the resultant displacement as well as the distance traveled. Distance traveled is easy. You just add all these up. So 10 plus 20 plus 10 plus 10 plus 5 5. So 10, 30, 40, 50, 60. So 60 blocks total traveled distance. The displacement. So the displacement is the distance from the start to the end. And we can figure that out using the Pythagorean theorem. We moved 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Oh, no, 15. It's just 15. Okay, count those blocks. 15, I believe. Okay, so we have 15 east total. And we went 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 15 north. Huh. Interesting. Interesting. Yeah, what's up, Jaden? Continuing on here. So 15 east, 15 north. Okay, so we got to find the resultant vector. So it's 15 squared plus 15 squared, and it's the square root of that to get the resultant vector. Square root of 15 squared plus 15 squared, and you get 21.2. So 21.2 blocks, and the direction would be northeast. Okay, next one, number 4. So we go 15 blocks east. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And 15 blocks north. 1, 2, 3, 4, 5, 6, I'm not even going to count them because it's just 2 of them. So 15 north, 15 east. Okay. The total distance traveled would be 30 blocks. And the total displacement would be the same because it's 15 and 15. So 21.2 blocks. So compare the values. They're the same. The same displacement, but different distances. This was just more of a direct way. Okay, next ones. Okay, a plane flies with a velocity of 52 meters per second east. And it's blowing 12 meters per second south. So I drew these the wrong way. I shouldn't draw them like that. Let me draw where I have some more space. I'll make some more space. How about that? So I'm going 52 meters per second east. Then I'm on 12 meters per second south. The resultant vector would be from the tail of this one to the head of this one. That's the resultant. Okay, so it'd be 52 squared plus 12 squared, and take the square root of that. We get 53.4. And that would be southeast. So you didn't have to include the direction, but I did anyway. Okay, number 6 says a mountain climbing expedition establishes a base camp and 2 intermediate camps, A and B. Camp A is 11,200 meters east and 3,200 meters above base camp. Camp B is 8,400 meters east and 1,700 meters higher than Camp A. Determine the displacement between base camp A and base camp and camp B. Okay. Sorry, of base camp and camp B. Sorry, base camp and camp B. So first we have to add the vectors that are in the same direction. So we're moving 11,200 east and then 8,400 meters east. So those are going in the same direction. So our total distance east is going to be 11,200 plus 8,400. So our total direction east is 19,600 meters east. Okay, so that's our total amount moved east. And then how high? So the first one is 3,200 meters above base camp. And then the other one is 1,700 meters higher than Camp A. So we're adding those two things together. So 3,200 plus 1,700, and we get 4,900 meters high. Okay, now if we want to combine these two and find the resultant or the displacement between the two, okay, we just square them and find the square root. So 19,600 squared plus 4,900 squared, and we take the square root of that. And we get 20,203 meters east and higher. Again, we don't really have to include the direction, but basically, if you were to go in a straight line from the base camp to Camp B, it would take you 2,203 meters. Or as they say, as the bird flies, the crow flies, right? So not only would you be going east, but you'd also be increasing your elevation. Okay, next one. A boat heads directly across a river, 12 meters per second. If the river flows 6 meters per second, find the magnitude of the resultant velocity. So 12 squared plus 6 squared, square root of that. So 13.4. Okay, and last one, we have 100 meters per second due north, blowing from east to west is 30 meters per second. What is the resultant velocity? So it's going to be 30 squared plus 100 squared. Take the square root of that. We get 104. Okay, and that's it. If you have any questions, please do let me know.